Hello guys, today we're doing LeetCode question 704, which is binary search. So I'll show you how to do a binary search pretty much. Question is, given an array of integer nums, which is sorted in ascending order and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm with O log n runtime complexity. So when you see questions that ask you to run the solution in runtime of O log n, it most commonly is binary search. So let me show you. Example 1 is input nums array, which is -1 0 3 5 9 12. Target is equal to 9. The output is 4. 9 exists in nums and its index is index of 4, which is here. Example 2, nums is -1 0 3 5 9 12. Target is 2. 2 is not an array, so it returns -1. You could do this with a simple for loop, but we have to do it. That is a runtime complexity of O(n). We have to do it in runtime of O log n. So let me show you pretty much what a binary search is and how to do it. So a binary search is, this only works, by the way, in a sorted array, but it's searching in halves. So for example, let's say we're looking for integer value of 9 in the example. We will look through this half first and this half. So as we know they're in size order, we check the middle value, which we'll say is this, and we know that 9 is bigger. So we stop searching this half, and now we search through this half. Now we get the middle value, and now we have 9, so then we return that. That is faster than looping through each value, because you have to check this value, this value, this value, this value, this value, and this value. Whereas here, we just check in halves, here, or here, and then we know it's on this half, so then we check here, and we found the value. And yeah, so let me show you how to do binary search. So the way we'll do it is we'll get the start value, which is equal to the beginning of the array, which is equal to 0. We get the end value, which is the length of the array -1, which gets the last value, which is equal to 5. And then we have to get a middle value. But first we loop through the array as long as start is smaller than or equal to end. So what we'll do is we check the mid value, and the mid value we add the start and the end and we divide it by 2. So for now, and then we floor it, so we round it down. So start plus end is 5, we divide it by 2 is 2.5, and we round it down, so mid is 2. So right now we are here. Let's say our target is 9, equal to 9. So we know that 3 is smaller than 9, which means that the value target will be on this half of the array. So then we set the start as this value, because we've already checked this value, we know it's not it, so we set the value as mid +1. So the start is now 3. And now we iterate through the while loop again. So we add 3 plus 5, which is 8, and divided by 2, so mid is 4. So we check the position at 4. 0, 1, 2, 3, 4, 9. Luckily that is a target, so we know that it's an index of 4, and we return 4. If the value was smaller, let's say the target was 0, here, as we get the index position from the beginning, we will start 0, the mid was 2. As we get the value of 3, we know that it's smaller than 3. So what we do instead is we set the end to this value, and so we loop through this half of the array. So in that case, we'll set the end to 2 minus 1, which is 1. And then we loop through the value again. 0 plus 1 is 1, divided by 2 is 0. Sorry, 0 plus 1 is 1, divided by 2 is 0.5. We round it down, so mid is now 0. Okay, now we're here. We know that -1 is smaller than 0, so now we have to create the start as the mid plus 1. So now start is 1. Now 1 plus 1 divided by 2 is 1. The reason now we're checking that we can loop through while start is smaller than equal to end is because if it was smaller than end, now we would break the while loop. But we are now at start and end at the same position, and this is the number we're looking for, which is 0. So we know that is a value of index mid, which is 1. So we return 1. Let me show you how to do this in code. Okay, so the first thing we do is we set the start value to 0, then we set the end value to the array length -1, which gets the last value in the array. Then we create a while loop. As long as start is smaller than or equal to end. It has to be smaller than or equal to end, not just smaller than, otherwise it won't work. Then we check, we get a mid. So mid is equal to math.floor. Math.floor rounds the number down. Then we set the start plus end, we add them together and divide them by 2. This gets our mid value. Then we check if the number at mid is smaller than target. As the array is in size order, we know that we have to check the right half of the array because target is bigger. So we set the start to mid plus 1. Else if the value at mid is bigger than target, then we know that it's on the first half of the array. So we set the end value to mid -1. Else, if it's neither bigger or smaller, we know we found the target. So we return mid, which is the index position. Else, if we don't find the target, we iterate through this completely. If we haven't found the target, we know it's not there, so we return -1. Let's see if that passes. Yep. Let's submit. Perfect. As you can see, this is the fastest time complexity. And it is a time complexity of O log n, as we're using binary search, which searches in halves rather than searching through the whole array. And it's a space complexity of O1, as we're only storing constant variables. Thanks for watching.